Yes, hello members. You are most welcome this day of today. I'm back, your teacher Saddam Hussein. I'm very proud that you people are really following, you are viewing, you are subscribing, you are commenting. That is a very good work that you people are doing. I want to appreciate everyone that what you are really putting down is important, and may the Almighty God bless you about that. Now, today we want to look at something about circles, that is under measurements. That is what we want to look at. Someone requested that I should also try to touch something about that because he wanted some clue about it. So they are saying that we calculate the perimeter of the figure. We calculate the perimeter of the figure. Remember, I told you that perimeter is the distance round a given figure. Perimeter is the distance round a given figure. Now, when they tell us to calculate perimeter of this figure, you'll realize that you have to get the distance from here. This is a dotted part. You're supposed to get the distance from here to there, from here to there, from here to there, here, like that. That's the distance that's around the figure. This dotted part is just imaginary, but the distance from this point to this one is 6, but it is not there. That's what they are meaning. That's an imaginary line. So when you calculate the distance around the figure, we shall not add from this point to the other point. We shall know why this one is important in our calculations. Now, in case we are calculating the distance round the figure, we should make sure that we have all the length that are required. When you check from this point to this point, we have already the measurement given as 15 centimeters. Then from here to there, this is the major arc. We don't have the length of this major arc. Then from this point to here, the length is also not given. Here is not given, but this one is given and the other one is given. So what do we do before we calculate the perimeter? Are we just going to add whatever we are seeing? 8 plus 15? No, we are supposed to follow the rule as it says that the distance round a given figure gives us the perimeter. Are we clear? So that's where we are going. So the first thing is we can choose either to calculate this distance first or the other distance first. Let us begin with this arc, this major arc which is there. Now when we look at that major arc, it looks like a semicircle. From here to there, it is a semicircle. So to calculate that length of that major arc, we shall say the length of the arc or the major arc is given by a half. Remember, a semicircle is a half of a full circle, and when we are calculating the distance round a circle, we always say pi d, the distance round a circle, or the circumference. Remember, circumference, distance round a circular object. So when you're calculating the distance round a circle, it is pi d. Now, if it's a half a circle, it's a half times pi d. That's the length of this arc that we want to calculate. Remember, diameter. When we talk about diameter, it is the distance from the circumference, from a standpoint of circumference to another point of circumference through the center, or the longest chord on a circular object. This is what we mean here. When we have a circle like this, through the center, this one from here is the diameter. So when we look at this part here is what we are having the other side. So length of the arc equals to a half times pi d. Pi is the ratio of circumference to diameter. When you divide circumference by diameter is what we call that pi. Remember, we did that work last time, how to calculate the pi how does pi come to be 22 out of 7? We did it and we are now aware. I don't want to go deep into that. Now from there, the length of the arc there is a half. Our diameter, I mean our pi that we are going to use is 22 out of 7. Then multiply by diameter. Diameter of this semicircular object from here, this is the arc. Now the diameter is running from here to there. That's where the 6 becomes important. So the diameter is 15 centimeters plus 6 centimeters, which gives us 21 centimeters. Now from there, what do? A half multiplied by 22 out of 7 multiplied by 21 centimeters, by 7 1 by 7 3 by 2 1 by 2 11. So that length of the arc is 11 times 3 centimeters, which gives us 33 centimeters. That's the length of that arc. From this point to that point is the length of that arc. Now, after calculating this one, we now have that 33. Which distance is left to be calculated? We have this from this to that. Now, when you take that figure out very well, we shall have something which looks like this. We shall have this. This is 8 centimeters. This is 6 centimeters. So what comes into your mind when you look at that kind of figure like that? Remember, this is a right angle triangle where we said that this is from here to here is what we call the hypotenuse. And for you to calculate the hypotenuse, we know that if this is your A, this is your B, and this is your C. So A squared plus B squared equals to C squared according to Pythagoras theorem. Now we have A squared. This is 6 centimeters, which is squared, plus B, which is 8 centimeters, which is squared, equals to C squared. Now this one, when you expand, is 6 centimeters multiplied by 6 centimeters plus 8 centimeters multiplied by 8 centimeters equals to C squared. What is 6 centimeters multiplied by 6 centimeters? That one gives you 36 square centimeters plus 64 square centimeters equals to that C squared. Now from that point, we now have something which looks like this. We have 36 plus 64, which is 100 square centimeters equals to C squared. So 100 square centimeters equals to C squared. To get the value of C, you get the square root in both sides. Now the square root of 10, remember we calculated last time, we told that when you get the square root, you use the prime factorization method to calculate it very well without any problem. So the square root of 100 is 10. Square root of centimeters is square centimeters remains centimeters, not square this time. So C squared, this one cancels, and we have C here. So that length is now 10 centimeters. Now if we have this length, we now have this length as 10 centimeters, we have that one as 33 centimeters. But remember we said the perimeter equals to total distance round a figure. So we are going to add. We now have everything. We shall begin with that 10 centimeters plus 8 centimeters plus 15 centimeters plus 33 centimeters. 10 plus 8 is 18 centimeters. 15 plus 33 is 48 centimeters. So which answer do you have there? 66 centimeters. That is the distance round that given figure. So that is how we will calculate it. If you are given such a simple question to work out, you realize that it's just something very simple. As long as you are able to identify the other side is missing by following the procedure and the method required. We are saying that calculate the perimeter of the figure below, and the figure, I told that this 6 is not put in the final answer. Why? Because it is imaginary, it is measured, but not part of the semicircle. But from here to here, it is part of it. But this one is dotted line. Whenever they give dotted line, it is only used like the way we have used it here to calculate this 10 centimeters, and then we have also used it to calculate the 33 centimeters. But when you are now adding, when you are getting the perimeter, we don't include it under our working. That is what I want us to work out for today. Now, with calculations about this, sometimes they can give you numbers. You should be able to identify the shape. Remember, in a semicircle, we can break that or divide the semicircle into two, and then we get those quadrants. Quadrants are a quarter of a circle, whereas semicircles are a half of a circle. Then there are some sectors that are, this one is also sector, fine, but there are some sectors that don't have angle 180 or angle 90 degrees. When it is 180, that's a semicircle. When it is 90, that is a quadrant. But now when it is 91, when it is 58, when those ones, those sectors, we shall see how to work them out when we are given such questions where we shall use the idea of angles directly. Even this one, you can use angles if it comes to their calculations, but in most cases we always prefer taking them as a half, because 360 degrees when it is the whole, then you pick 180, which is for a semicircle, you divide by 360, it gives you a half. That's why we say a half pi d. Then the other one, we call it a quarter, because when you pick 90 degrees out of 360 degrees, when you reduce, you get 1 out of 4. That's the only thing, by the way, but they are all the same. The only thing is that this one, we can simplify it. Someone can say, me, I don't need to use a half, I need to put directly 180 out of 360. There is no blame there. But with these calculations, I only wish that we should be very careful when we are identifying how to realize here that when this distance is missing, don't just add to finish up that because you want to hurry, because these are section B numbers which require you to first of all calculate the missing sides, because there is marks given for every step here. So you are supposed to be very, very careful when you are calculating this. I hope you have understood me right, and after this I will give you a very simple exercise which I don't think any of you is going to fail, and it's going to be in form of words, that is calculate. I hope you are following. Calculate the perimeter of a quadrant. Calculate the perimeter of a quadrant. Calculate the perimeter of a quadrant whose radius is 14 decimeters. Calculate perimeter of a quadrant whose radius is 14 decimeters. Just calculate it. I told you, a quadrant, this is how you are going to draw a quadrant. So that is, I've already given you how it must look like. This is how I want you to draw it. So I want its perimeter of this quadrant here. Remember, perimeter is the distance around a given figure. The distance around a given figure is what gives us, or is what defines the perimeter. Thank you very much for attending. I want to, in a special way, appreciate my colleagues who are outside there. I told you that we should work together. What has gone right and what has not gone right, let us keep commenting Let us keep going on together as brothers and sisters, as everything can be done the right way. May God bless you and keep aware. Thank you very much.